All right, so you know how much I love getting into the nitty-gritty of AI research. And you found a fascinating paper this week about recurrent neural networks.
The really interesting deep dive into how we can make these AI workhorses even better.
And when we say better, we're not just talking about making them bigger or faster, but really focusing on how they learn.
Exactly, because one of the biggest challenges in AI is this issue of overfitting.
Overfitting, right? So it's like when you cram for a test,
Yeah.
you memorize all the answers, but you don't actually understand the material.
Exactly. And just like with that friend we all had in school who could ace a test but couldn't explain the concepts to save their life.
Oh, yeah, I definitely knew someone like that.
We want our AI models to be more than just good memorizers.
Right.
We want them to be able to take what they've learned and apply it to new situations, to new data they've never seen before.
So how do we do that? How do we make sure our AI isn't just a glorified parrot?
Well, that's where this research comes in, and it focuses on a technique called dropout.
Dropout. Okay, I've heard of that, I think.
Yeah, and this paper looks at using it specifically with a type of recurrent neural network called LSTMs.
LSTM's long short-term memory units, right?
Got it. They're designed to handle those sequential types of data like language or music where the order of things really matters.
So like remembering the plot of a movie or following the steps in a recipe.
Exactly. LSTMs are like the memory champions of the RNN world.
That makes sense. But then why doesn't regular old dropout work well with these LSTMs? If it helps with overfitting in other neural networks, why not here?
That is the million-dollar question this research tackles. You see, dropout is kind of like adding a little bit of controlled chaos during the training process.
Controlled chaos. I like it.
Right. Like imagine you're trying to learn a new skill.
Okay.
And every now and then someone randomly throws a wrench in your plans, forcing you to adapt and find a new way to accomplish your goal.
So you're saying it's like adding a bit of unpredictability to the learning process.
Precisely. And in the world of neural networks, we do that by randomly silencing some of the neurons during training.
Silencing them like they're on a temporary break?
Yeah, exactly. It's like making those neurons take a little coffee break, preventing them from becoming overly reliant on each other.
Okay. I'm starting to see where this is going. It's like if you always study with the same study buddy, and then suddenly your study buddy has to take a call,
Yeah.
you're forced to figure things out on your own for a bit.
Right, and that actually makes your understanding stronger in the long run because you're not just relying on your study buddy to fill in the gaps.
Yeah.
But here's the catch. With LSTMs, they have this very specific, intricate internal system for holding on to information over long sequences.
Okay.
And applying dropout in the usual way can actually disrupt that system. It's like cutting the thread of a carefully woven story.
Oh, I see. So we need to be careful about how we apply this dropout with LSTMs. We can't just throw it in randomly and hope for the best.
Exactly. It's all about being strategic.
So it's like we need to be more strategic about where we sprinkle in this dropout.
That's the really clever part of this research. They realized it's not about getting rid of dropouts altogether, but about applying it more selectively.
Selectively. Okay, so how did they do that?
Well, instead of applying dropout to those crucial memory pathways within the LSTM, they focused on what are called the non-recurrent connections.
Non-recurrent. Now that's a mouthful. Are those like the less important connections?
It's a bit more nuanced than that. Think of it this way. The recurrent connections are like the main highways of information flow within the LSTM. They're responsible for carrying those long-term dependencies.
Okay.
The non-recurrent connections are more like the smaller roads and side streets. They provide context and support, but they don't carry the same weight in terms of long-term memory.
So instead of shutting down the entire highway system, they're just putting up a few detours on the side roads.
Exactly. It's a subtle but powerful distinction. And what's amazing is that this seemingly small adjustment had a ripple effect across a whole bunch of different AI tasks.
Really? We're not just talking about language anymore.
Nope. They tested this modified dropout technique on everything from language modeling to speech recognition and even get this image captioning.
Hold on, image captioning too. That's where the AI tries to describe what's happening in a picture, right?
You got it. So we're talking about applying this technique across vastly different domains and seeing positive results.
So what were some of the specific improvements they saw? Give me the highlights.
Well, let's start with language modeling. They used a standard benchmark called the Penn Tree Bank dataset, which is kind of like the gold standard for testing language models.
Gotcha.
And with this targeted dropout, they saw a significant improvement in the LSTM's ability to predict the next word in a sequence. You know, like when your phone tries to guess the next word you're going to type.
Yeah.
It's like they gave that AI a boost in its language skills.
Fascinating. So we're talking about a more coherent, more eloquent AI, all thanks to a little strategic dropout.
And it's not just about eloquence. They also tested this technique on a speech recognition task using a relatively small Icelandic speech dataset.
Icelandic. Wow, that's pretty niche. Why Icelandic?
Because it's a great example of how overfitting can be a major problem when you have limited training data.
Right? The AI can start to memorize the quirks of that small data set instead of learning the underlying patterns of the language itself.
Exactly. And with this modified dropout, they saw some really promising improvements in the LSTM's accuracy, even with that limited Icelandic data.
So it's like instead of the AI getting thrown off by unfamiliar accents or phrases, this dropout tweak helps it generalize better to new speakers.
You're getting it. It's like teaching the AI to be a more adaptable listener, even when it encounters unfamiliar dialects or ways of speaking.
This is really making me think differently about the whole concept of dropout. I always thought of it as a blunt instrument, but this research shows how we can use it with more finesse.
And that's what's so exciting about this field. There's always something new, to discover some new way to tweak these algorithms to unlock their full potential.
So we've talked about language speech and even a little bit about speech recognition, but I'm dying to hear more about those image captioning results. That feels like a whole other level. So we talked about this modified dropout technique being used to improve language models and even speech recognition, but now image captioning. That feels like a whole different ballgame. What were the results like there?
Well, they took this dropout strategy and incorporated it into an existing image captioning model. And get this, it actually started performing as well as what's called an ensemble of multiple models.
An ensemble, like a whole team of AI models working together.
You got it. Instead of having just one AI trying to describe an image, you have a whole bunch of them, each with its own strengths and weaknesses.
Okay.
They each take a crack at describing the image, and then their answers are combined to produce a hopefully even better caption.
So it's like getting a second opinion or even a third or fourth opinion to get a more well-rounded view of what's going on in the picture.
Exactly. And ensembles can be really powerful in machine learning. But there's a catch. They can be really computationally expensive because you're essentially running multiple models instead of just one.
Right. I can see how that would eat up a lot of computing power.
Exactly.
Right.
But here's the really cool part. This research showed that by using this carefully applied dropout, they could achieve comparable results with just a single model.
So it's like getting the wisdom of the crowd without the overhead.
Precisely. It's all about working smarter, not harder.
I love that. And it really highlights how this research isn't just about theoretical improvements in AI. It has practical implications for making these technologies more efficient and more accessible.
Couldn't have said it better myself.
Yeah.
And it really drives home the point that sometimes the biggest breakthroughs come from these subtle but insightful tweaks to existing algorithms.
It's like that old saying, the devil is in the details.
Absolutely.
Yeah.
And in this case, those details involved understanding the unique structure of LSTMs and figuring out exactly where to apply dropout for maximum impact.
So as we wrap up this deep dive, what would you say is the biggest takeaway for someone who's not an AI researcher? Why should they care about dropout and LSTMs and all this technical stuff?
That's a great question. And I think the answer is simple. This research is a perfect example of how we're constantly pushing the boundaries of what's possible with AI. It's about finding more efficient ways to train these models, making them more accurate, more adaptable, and ultimately more useful in the real world.
It's like we're taking these powerful tools and fine-tuning them to be even more precise, even more capable.
Exactly. And the applications are everywhere from improving language translation to developing smarter medical diagnosis systems to even creating more engaging and creative AI-generated art and music.
It's mind-boggling when you think about it, and it all starts with these fundamental research questions like how can we optimize dropout for LSTMs?
And that's the beauty of this field. There's always a new challenge to tackle, a new puzzle to solve. And each discovery opens up even more possibilities for the future.
It's like every answer leads to even more fascinating questions. Well, on that note, I want to thank you so much for taking us on this incredible deep dive into the world of recurrent neural networks and dropout.
It's been my pleasure.
And to all our listeners out there, keep those brains engaged and keep asking those big questions because that's how we move the field of AI forward.